Hello everyone. Today's topic of discussion is the data sufficiency of GMAT. So what we'll be doing in today's topic is that, or in today's video is that, I'll be discussing 5 different questions based on the concept of data sufficiency. In this video, we will not be discussing the very basics of data sufficiency, like what do options A, B, C, D, E stand for. Okay. So if you're watching this video, I'm assuming that you know what the options stand for. Okay, what's the chronological order of the options? And in this, we'll simply learn like how to solve a particular question. Okay, what's the approach? What's the correct way of solving a particular data sufficiency question? Okay, all right. So let's begin. So if you know what is data sufficiency and how do you solve questions pertaining to data sufficiency, then you can pause the video and you can try the question first by yourself, and then you can play the video back in order to understand on how to solve the particular question. All right, let's see. So it says that if t and x are integers, what is the value of x? So x square by t square is 4 by 9, x is greater than 0 and t is greater than 0. Okay, so let's start with statement 1. So statement 1 says that x square by t square, this is equal to 4 by 9, which means we can also say x by t whole square is basically equal to plus minus 2 divided by plus minus 3 whole square. So we can say that x by t is basically equal to plus minus 2 divided by plus minus 3. Okay, so we can either have, you can put it in this way, that is, we can either have x is equal to 2k and t is equal to again 3k, or you can say that you will have x is equal to negative 2k, and in that case t will be equal to negative 3. So these are like the possibilities that we have. So do we have a conclusive answer, like what's the value of x? No, we don't have a conclusive answer. Okay, there are like many possibilities which can happen. Okay, so from statement 1 alone itself, we cannot answer the question. So we know the chronological order, it is D, A, B, C, E. So A goes out, which means D also goes out. Now coming to statement number 2, statement number 2 says that x is greater than 0 and t is greater than 0. Now the question is, t and x are integers, what is the value of x? Now if x is greater than 0, x being integer and greater than 0, it can again have infinite possible values. It can be 1, 2, 3, 4, 5, 6 and so on and so forth, right? So which means statement B alone also will not give us a conclusive answer, so B also goes out. Now if I combine the two statements, so x greater than 0, t greater than 0 and x by t square is equal to plus minus 2 divided by plus minus 3 whole square, we can say that the only possibility that we have is x by t should be equal to 2 by 3. X by t should be equal to 2 by 3. Now here is a catch. Now when you say x by t is 2 by 3, now most of the students would say, okay, the answer is C, x is 2, t is 3. But this is again incorrect. You're missing out on the point that when you say x by t is equal to 2 by 3, the ratio is given to you. That is, if x is 2, then t is 3. But what if x is 20, then t is 30? Right? What if x is 15? In that case, oh sorry, what if t is 15? In that case, x will be 10. So this, even when you combine the two statements, you will get the ratio. What you will get is the ratio. You will still not get the conclusive answer. So C also goes out, and the correct answer is option number. The correct answer is question number, option number. That's the answer. Okay. All right. Let's move on to the next one. So pause the video if you want to try this question before I solve it. Okay, the cost of a certain phone call was $8 for the first 2 minutes and 0.15 for each additional minute after the first 2 minutes. Okay, so let's pen down this information. So that is $0.8 for the first 2 minutes, and it is $0.15 per minute for every additional minute. Okay. Did the phone call last lesser than 10 minutes? Okay. So let's say this guy was on the phone for T minutes. Okay. TES. My bad. So this guy was on the phone call for T minutes. So for the first two, he will have to pay 0.8, which means he is now left with T minus 2 minutes, and for every minute, he is supposed to pay 0.15. So we can say that the overall cost in terms of T will be equal to 0.8 plus 0.15 T minus 0.3, which will simply be equal to 0.5 plus 0.15 T. The question is, did the phone call last lesser than 10 seconds? So the question is T less than 10? This is the question. Is T less than 10? Okay, the first one says that the cost of the phone call was less than $4. The total cost of the phone call was less than $4, which means we can say that 0.5 plus 0.15 T should be less than 4. So 0.15 T should be less than 3.5, which means T should be less than 3.5 divided by 0.15. Okay. So we just need to know the approximate value of this, that is 3.5 divided by 0.15, which will basically be equal to, it will be roughly, I can say that now I can solve this by T will be less than 35 divided by 1.5. Now I may not know the exact value of this, but I can roughly say that since I know that 20 into 1.5 is 30. Okay, so this will be greater than 20 for sure. This will be roughly around 23, 24. So let's say T is less than 23 or 24, whatever value you want to put. Now I'm like, in this case, what I'm doing is I'm approximating because I'm looking for a value which is lesser than 10, right? Now in this case, even if I have done an incorrect approximation, let's say even if the value was 23, it will still, it won't still make an impact on your answer, okay? Whether you write T less than 24 or less than 23, it won't make an impact. Now when you say T less than 24, now T can be anything less than 24. T can be 23, T can be 22, T can be 10, T can be 5, 6, it can be anything. So do we have a conclusive answer from this statement? No, we don't have a conclusive answer from this statement. So that means if we can't have a conclusive answer, so if I write the chronological order D, A, B, C, E, that basically means D goes out and A goes out. Now the second one says that cost of the phone call was greater than 3.2, which means now we can say that from the second statement, this was the first statement, from the second statement we can say that 0.5 plus 0.15 T should be greater than 3.2, which means 0.15 T should basically be greater than 2.7. So T is greater than 2.7 divided by 0.15. Now again, you don't have to solve this. Okay, see that's the best part about data sufficiency. Again, you don't have to solve this. If you want T to be 10, if you want T to be 10 or greater than 10 or less than 10, let's take to 10 first of all. If you want T to be 10, so when you talk about this, okay, let me remove this conclusion of statement 1 or the solving of statement 1. Okay, we'll keep the conclusion. So if I want T to be 10, So in the denominator I have 0.15. If I want t to be 10, then I need my numerator to be 1.5, right? Because 1.5 divided by 0.15 will be exactly equal to 10. If I increase the numerator, then the overall fraction will increase. If I decrease the numerator, then the overall fraction would decrease. That is, if in the numerator, if you have a value which is greater than 1.5, then the value of t will be greater than 10. If in the numerator you have a value which is less than 1.5, then the overall value will be less than 10. Now in this case, it's 2.7 divided by 0.15. So one thing is for sure, that no matter what happens, this value will give you the conclusion that t is greater than 10. How much greater? That's not my concern. How much greater? That is actually not my concern. But it is greater, that's it. So the question was, is t lesser than 10? That's the question which we are trying to answer. So the answer from the second statement is no, t is not greater than 10. Sorry, my bad. No, t is not lesser than 10. I'm sorry. No, t is not lesser than 10. Okay. See, again, try to understand, in case of data sufficiency, you're not looking for an affirmative answer. You're looking for a conclusive answer. Affirmative means yes. We're not looking for yes. We're looking at whether the information given in the statement provides you with a conclusive answer or no. And no is definitely a conclusive answer. For example, if someone asks me, do you live in California? My answer is no. That's a conclusive answer. If someone asks me, do you live in New Delhi? My answer is yes, I do. That's again a conclusive answer. We're looking for a conclusive answer. Okay, we are not looking for an affirmative answer. So don't fall into that trap. Okay, so your answer is simply statement B. That's it. Okay, let's move on to the third one. What is the value of x if x and y are two distinct integers and their product is 30? So x and y are two distinct integers and their product is 30. So let's see what all possible cases do we have. So I can have 1 into 30. Then I can have 2 into 15. I can have 3 into 10. I can have 5 into 6. These are the only 4 positive possibilities. Now what happens in a question like this is, usually students forget that they have to take the negative part also into the consideration. Okay, they forget that they have to take the negative part into the consideration. So let's take the negative part also before we actually move on to the statement 1 and statement 2. So negative part is negative 1 into negative 30, negative 2 into negative 15, negative 3 into negative 10, and negative 5 into negative 6. These are the negative possibilities also. Okay. So first one says x is an odd integer. Now negative numbers are also odd in nature. Okay. So x is an odd integer. So x can be like, there can be multiple values of x. X can be 1. It can be negative 1, x can be 15, negative 15, 3, negative 3, 5, negative 5. All of those are possible. So do we have a conclusive answer from statement A? No, we don't have. So D, A, B, C, E, A goes, D goes. Second statement says that x is greater than y. X greater than y, x can be 30, x can be 15, x can be 10, x can be 6, can be negative 1, can be negative 2, can be negative 3, and can be negative 5. So do we have a conclusive answer from B? No, we don't have. So B also goes out. B is not our answer. Now if you combine the two, now in this case, you can very well say that, okay, answer will be E, because even after combining, we will have a lot of possibilities. But if you would have written only the positive possibilities, then x being an odd and x greater than y, there would have been only one possibility, which is 2 into 50. And you would have marked your answer as C, fallen into the trap and not taking the negative numbers into consideration, and you would have got the wrong answer. Now if you take the negative part also into the consideration, then apart from 2 comma 15, you will have negative 1 and negative 30. You will have negative 3 into negative 10, and you will have negative 5 into negative 6, also part of your solution. The question says two distinct integer. It does not use the word positive. It does not use the word positive. So again, don't fall into that trap. Okay. So C also goes out, and your correct answer is option number B. All right, let's move on. Okay, so is y an integer? Y cube is an integer. Okay. Now it says y cube is an integer. So if you start with statement A, when you say y cube is an integer, so you can say that y will be equal to integer to the power 1 by 3. Now not every integer or not cube root of every integer will give you an integer. For example, if you do 8 to the power 1 by 3, it will definitely give you 2. But if you do 7 to the power 1 by 3, it will not give you an integer value. So if y cube is 8, then y is 2, fine. We know that. But if y cube is 7, do you know the value of y? No, you don't know the value of y. Right? So if y cube is an integer, then it's not necessary for y to be an integer. It's not possible. Okay. So we can do D, A, B, C, E. So A goes, D goes. Second statement says that 3y is an integer. So if 3y is an integer, that means y should be in the form of integer divided by 3. Y should be in the form of integer divided by 3. Now it may happen that this integer is a multiple of 3. It may also happen that it is not a multiple of 3. So if this integer is a multiple of 3, then yes, y is an integer. But if it is not a multiple of 3, then no, y is not an integer. For example, 3y is 2. So y is 2 by 3, not an integer. 3y is 6. So y is 6 by 3, which is 2. So yes, it is an integer. So do we have a conclusive answer? No, we don't have a conclusive answer. So B also goes. Which means now we have to combine both of them. Now we want y cube as an integer, and at the same point of time we also want 3y to be an integer. That will only happen if y is an integer. That will only happen if y is an integer. Let's say you take this case that when you say 3y is an integer, you go with the case that this integer is not a multiple of 3. So y will become something not in the form of 3k divided by 3. Right? Now, if it is something in the form of not a multiple of 3 divided by 3, and when you'll cube this, you will basically cube this entire number, right? Now the numerator is not a multiple of 3, then its cube will also not be a multiple of 3. Let's write it to be some value 3m divided by 27. Now this is not an integer. Because if 3m divided by 27 were to be an integer, then m needs to be a multiple of 27. Now if the number 3k itself is not a multiple of 3, then from where will you get 27? It's not possible, right? So the only possibility if you want y cube to be an integer and 3y to be an integer is that y has to be an integer. That's the only possibility, nothing else can happen. Which means when you'll say C, C will be the correct one. So this case and this case, they both will be the common cases. Okay, so the answer is C for this one. Okay, let's do one more question for this video. So for this one, this is again a simple one. So in this video, I have basically taken up simple questions which you can probably solve. In the upcoming videos, I'm going to take difficult ones also. Okay. All right, let's see what we can do with this one. So is y equal to 3? That's the question. First statement says that y minus 3 into x minus 4 is 0. Now if y minus 3 into x minus 4 is 0, there are three conclusions that you can draw. Y is 3. We do not know anything about x, or x can be anything, doesn't matter. Second is y can be anything. We do not know about y, but x is equal to 4. And third is x is equal to 4 and y is also equal to 3, because 0 into 0 will effectively give us 0. Right? There are three conclusions to this. So the question is y equal to 3? So in case number 1, yes it is. In case number 2, sorry, we do not know that. In case number 3, yes it is. Do we have a conclusive answer from statement A? No, we do not have a conclusive answer from statement A. So D goes, A goes. Second one says that x minus 4 is equal to 0, which means x will be equal to 4. Now if x is equal to 4, do you know anything about y? No, you do not know anything about y. So can I make any conclusions regarding y from statement 2 alone? No, I can't do that. So B also goes out. Now if I combine both of them, then I'll have to see where all x is coming out to be 4. So x is 4 in this case and x is 4 in this case. That's for sure. Now in the rightmost case, when x is 4, then y is also 3. But in the middle case, when x is 4, y can take any value possible. So even after combining, do we have a conclusive answer? No, we don't have a conclusive answer. So this is the correct option that you are doing. Okay. These are like some easy questions on data sufficiency. I hope you have enjoyed the video. Okay, so stay tuned for more videos on data sufficiency for your GMAT preparation. Okay, and don't forget to subscribe the channel for more videos and exam related content on SAT, GMAT and GRE. And if you're looking for any personalized classes, you can always connect with us. Keep watching and keep learning. Thank you so much, guys. Okay, take care.